Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics paper 4.3 for October-November 2023. And these are questions from 1 to 4. Question number 1, a particle is projected vertically upwards from the horizontal ground with a speed of u meters per second. The particle has height s meters above the ground at times 3 seconds and 4 seconds after projection. Find the value of u and the value of s. In my sketch here, I'm having the particle which is projected vertically upwards. Okay, and then we have a certain height here. Let's say height s. Yes, it is given as s. Now, it is above this height at times 3 and 4. So that means it will take 3 seconds, okay, to reach this position, to move from here up to here. It will take 3 seconds. And then when it clocks 4 seconds, it will now be coming back. So 4 seconds will be here when it is like this. So it will be the same distance from the horizontal ground. Okay, so that means we can have the time spent here by the time spent when it is at least s meters above the ground. So I can subtract them. That's the time spent above s meters is going to be 4 minus 3, which is 1 second. Okay, that is 1 second. And since this projection here is symmetrical, that means the time taken to move up here is a half of this one. So a half of 1 is, of course, 0.5 seconds. It is the same time taken to move from this maximum height to here. It's also 0.5. Then here, of course, v is equal to what? 0. Now, at maximum height, that v is equal to 0. So using v, which is equal to u plus 80, the final is 0. Okay? Initial is the u it was projected with here, meters per second, which we don't know. So that is u. Since it was projected up, then the acceleration is negative 10. Okay? And the time is going to be 3 plus the 0.5. Remember, it takes 3 seconds to move up to here, right? Then now the 0.5. So this one will give us 3.5 times 10, that is minus 35. So then when it crosses, that means u is equal to 35 meters per second. So that is the initial speed it was projected with. Then next, we are supposed to find the s. Now, I can use s is equal to ut plus a half at squared, because I know the time taken to cover this s, which is 3. So that means I will get our u we have gotten, which is 35, then times the 3, then plus a half. Since it is going up, acceleration is negative, so times negative 10, and then the time is 3. So here we shall have 105, and then minus, it should be 5 times 9, 45. And then we get 60 meters. That is that. Question 2. A machine for driving a nail into a block of wood causes a hammerhead to drop vertically onto the top of the nail. The mass of the hammerhead is 1.2 kilograms and the mass of the nail is 0.004 kilograms. The hammerhead hits the nail with speed v meters per second and remains in contact with the nail after the impact. The combined hammerhead and nail move immediately after the impact with speed 40 meters per second. All right. Then they are saying part A, calculate V, giving your answer as an exact fraction. Now here we are going to use the principle of conservation of momentum because we are having two particles which are colliding. Okay. This one here collides with this one. Now, and you know that we have momentum before collision is equal to momentum after collision. So I'm going to have, this is momentum before collision is equal to momentum after collision. Now, the mass of the hammerhead is 1.2. So, times its speed, which I don't know, okay? Then plus the nail is stationary, okay? So its momentum is 0. And then after collision, since these two stick together, and then the nail is driven into the wood, that means we get a coalesced particle. So the two masses, we add them 1.2, then plus the 0.004, which is the mass of the nail, and then times the speed of the particle after impact is 40, so times 40. Okay, so meaning our V is going to be equal to 1.204 times 40, then we divide by 1.2. What do we get? 1.204 times 40, then we divide by 1.2. We get 602 out of 15. And they told us to give our answer in the exact fraction. So I'll write here 602 out of 15. Don't write your answer to 3 significant figures. Follow the instructions. Okay. Then part B, they're saying that the nail is driven 4 centimeters into the ground, into the wood. Find the constant force resisting the motion. Now, if this nail is driven into the ground, that means it comes to rest after 4 centimeters. Okay? Let me write it. The nail comes to rest after 4 centimeters. And of course, since the SI unit for distance is meters, this one is equal to 4 over 100, which is 0.04 meters. Now using V squared, which is equal to U squared plus 2AS, the final is 0. The initial is 40 squared, then plus. Since they are moving down, now we need to find the acceleration. Then from there, we can use the F is equal to MA to find the resisting force. So we are going to have 2A, and then times the distance is times 0.04. Okay. Now, of course, this A is going to be negative. So when this one crosses, because it is decelerating, it is coming to rest automatically, this one has to be negative. So we have negative 1600, and then we can divide by the 0.08 when you multiply 2 with 0.04 to get the A. What do we get here? 1600 divided by 0.08. It gives us 20,000. So acceleration is equal to negative 20,000 meters per second. Okay. Then I have this particle here. Just draw something small here. So this is the head of the nail. As it is going down, the combined particle, the nail and the hammerhead, their combined mass is 1.204 grams. So the weight is going down, and then there is a resistance force here, okay, acting upwards. So like I said, we are going to use F is equal to MA. So we shall have, since the movement is down, okay, we shall have the weight here 1.204 G. We subtract the R, which is equal to 1.204 times the A. So meaning we shall have 1.204 times 10, then subtract 1.204. Okay, let me actually extend it here. So we shall have 1.204 times 10, then minus 1.204 times the negative 20,000 we have gotten for acceleration. Then this one is equal to R. I have brought this one here and this one this side. Okay, so putting this in the calculator, what will be our R? Our R is going to be 1.204 times 10, then minus 1.204 times negative 20,000. So that is the fraction there, 6023 over 602301 out of 25. But maybe I think if it is divisible by 25, then it is a terminating decimal. So this is 24092. I can write 24092.04 newtons. So that is that. Question 3. A block of mass 8 kilograms slides down a rough plane inclined at an angle of 30 degrees to the horizontal starting from rest. The coefficient of friction between the block and the plane is mu. The block accelerates uniformly down the plane at 2.4 meters per second. And then they are saying draw a diagram showing the forces acting on the block. And like we have always seen, that you have to master the art of drawing the diagrams to indicate the forces that are acting on the particle. So if this is my diagram here, I can put the block here, just like that. And then here I'll have the normal reaction, which is perpendicular to the plane. Then here I have the here I have the weight. The weight is here acting this way. Then this weight here is tilted to the same angle. So this one here is 30 degrees. Even this one here is 30 degrees. So this is 80G. And then now here we shall have the, I can even make this one dotted. Okay. The vertical component of the weight here, which is 8G. Then cosine of 30. That is resolving, so we close in this one. And then when we open it, we shall have mg sine. So this is 8g sine of 30. So here we have the normal reaction since the particle is on the plane. And then they are saying that a particle of mass 8 kilograms slides down. So since it slides down and this is a rough plane, then the frictional force acts upwards because for it opposes the motion. So here we shall have mu r. Okay, so those are the forces acting on the particle. Okay, but then we shall not consider this mg here. The ones that we are going to take into account are these ones which are perpendicular to the plane and also the ones which are parallel to the plane. Okay, that is that. Then find the value of mu. So we don't have vertical motion. So vertical motion, I mean perpendicular to the plane. So that means this r is equal to this. Okay, so Vertically, our R is equal to 8G, G which is 10, then cosine of 30. Cosine of 30 is root 3 over 2. So meaning I will have 40 root of 3. Okay. Now horizontally, we are now going to use our F is equal to MA. Okay. So we shall have the 8G, then sine of 30 minus the resistance force mu R. R we have seen it is 40 root 3, which is equal to the mass. Mass of the block is 8 kilograms. So 8, were we given the acceleration? Yes, 2.4 meters per second. 2.4 meters per second squared. And then we know that sine of 30 is a half. So 8 divided by 2, that will be 40 here. Then minus 40 root of 3 of mu. Then 2.4 times 8. We get 19.2. This is 19.2. So meaning I can say 40, bring this on this side, and then we get minus 19.2, which is equivalent to 40 root of 3 mu. That is when this one crosses, becomes a positive. And then our mu is going to be this 40 minus the 19.2, and then we can divide by 40 root of 3. Then what do we get there as our answer? 40. We have 40 minus 19.2. Then we divide by 40 root of 3. So we get all of those, but so 3 significant figures, I can have 0.300. In other words, our mu is equal to 0.3. So mu is equal to 0.3. That is that. Maybe I can also pick the exact value as 13 root 3 over 75. 13 root 3 over 75. In case we need to use it in the next part, then I will use that exact one. Find the speed of the block after it has moved 3 meters down the plane, that is part C. So I can use V squared is equal to U squared plus 2AS. So our V is therefore going to be the square root. Since this particle here started from rest, okay, they said it here, it was starting from rest to slide down. So that means the initial is 0. So we shall have 0 squared, then plus 2, then times the acceleration, which was given as 2.4, and then the distance is 3. Okay, and you get the square root of this one is 14.4, and then when we get the square root of that, what we get? Square root of 14.4. That is 6 root 10 over 5, which is 3.79 to 3 significant figures. So 3.79 meters per second. That is to 3 significant figures. Question 4. A car has mass 1,600 kilograms, but the car is moving along a straight horizontal road at a constant speed of 24 meters per second and is subject to a constant resistance of magnitude 480 newtons. Find in kilowatts the rate at which the engine of the car is working. Now, they have talked about constant speed, meaning acceleration is equal to what? Is equal to 0. Keep that. Now, this is the car. It is, let's say, moving forward. Here it has the driving force. It also has the resistance to motion, 480 newtons. Okay. Now, using F, which is equal to MA, that means the driving force here minus the resistance force, then this one will be equal to 0 because acceleration is 0. And like I've always said in our videos, that the driving force is always equal to the resistance force if there is constant speed. Okay, now power is the rate of doing work, so we shall have power which is equal to the driving force times the velocity. Rate of doing work, we look at work over time. Okay, and work is force times the distance, then over time, and distance over time is the speed. So that's why we say force then times the speed. Now the driving force is 480, and then the speed given is 24. So multiplying these ones, what we get? We have 480 times 24. That one will give us 11520, and then we can divide it by 1000 to write it in kilowatts. So it will be 11.52 kilowatts. So don't write it in watts, they said kilowatts. Simple instructions. All right, then the next one here, they are saying the car now moves down a hill inclined at an angle of theta to the horizontal, where sine theta is 0.09. The engine of the car is working at a constant rate of 12 kilowatts. The speed of the car is 24 meters per second at the top of the hill. 10 seconds later, the car has traveled 280 meters down the hill and has a speed of 32 meters per second. Part B, given that the resistance is not constant, use an energy method. So strictly they want energy method to find the total work done against the resistance during the 10 seconds. When you use F is equal to MA, okay, and you also use, because there you are going to find the acceleration, then after that you can use F is equal to MA, you get the acceleration. Then after you can use V squared is equal to U squared plus 2AS. Okay, also there you can be in position to find the value that we are looking for, but they said energy method, so we have to stick to this. Now in my sketch here, just a simple sketch here, I have this car up here. Okay, now this car is sliding down, so it has the driving force, and then it also has a resistance force which we need to look for. So since here it starts when it has a speed of 24 meters per second, that means that here there is kinetic energy due to this speed, but there is also potential energy due to this vertical height generated. Okay, so there is vertical height here, and then the angle here is theta. Then the car will now come down here, but by the time it reaches down here, it is with a different speed, which they have said is 32. So let's say V here is equal to 32 meters per second. So because of this speed, the particle will have kinetic energy here, and using this as our reference point, then it won't be having potential energy. Okay, all the vertical height would have gone. So that is why I'm not having potential energy down here. And then we are having 280 meters here traveled. Okay, then this one takes 10 seconds to move there. Now we are supposed to use work done. Okay, work done by the driving force. Work done by the driving force, then minus work done against resistance, then this one is equal to the change in mechanical energy. Okay, mechanical energy is the sum of potential energy and kinetic energy. Potential energy is mgh. Kinetic energy is a half mv squared. Now, work done by the driving force. What is the work done by the driving force? We need to know the driving force, but we don't know it. However, we know the rate at which the work is being done. And this one took place for a period of 10 seconds. Okay, so meaning, since we know that power is equal to work over the time, so I will say work done by the driving force over the time taken. So when I cross multiply, I will have work done by the driving force is equal to the power then times the time taken. Okay, this is what I'm going to use here. So I will have the power is 12 kilowatts, so it is 12,000 then times 10. Okay, times 10 seconds, then minus work done against resistance, that is the one we are looking for, then is equal to change in mechanical energy. We get the final minus the initial. So for final, we have only kinetic energy. So I will say a half times the mass. The mass was given as 1,600. So the mass is 1,600, then times 32, then squared. Then from there, we shall subtract. So initially, we have the mgh. However, since here this is a right angle triangle, I can have sine of that angle theta is equal to h over the hypotenuse, which is 280. So meaning h is going to be equal to 280 times the sine of theta. Okay, now this one, I will bring it here, 280 sine of theta. So when I'm substituting here to find the potential energy, I'll have the mass, which is 1600, times the g, which is 10. Then now the h is 280 sine of theta. Okay, but sine of theta, I can actually put its value. It was given here as 0.09. You see, 0.09. So I'm going to substitute here times 0.09. So this one here, then plus the kinetic energy, which is a half times 1600, then times what? 24 squared. Now what is left is for us to find the work done against resistance. So here I'm going to simplify this, the change in kinetic energy, this one and then this one all together. Okay, now a half of 1600 is going to be 800. So 800, then inside here I can put 32 squared, then minus 24 squared. So altogether this one gives me 3584 and then minus how about this one here, all of it together, what does it give? So we shall have 16000 times 280 times 0.09. That one is 403. We have 403,200. 403,200. So meaning if I take this one this side, it will be a positive. So 120,000 minus 358,400, then plus 403,200, then will give us the work done against resistance. So therefore, what is work done against resistance? 120,000 minus 358, then 400 plus 403,200. So this one gives us 164,800 joules. 164,800 joules. If you want to write it in kilojoules, you will write 164.8 kilojoules. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.